right, Mr. True. Okay, if you want to see tangent and cotangent graph with a bunch of transformations like phase shifts and vertical shifts, this is not the video for you. Watch the next one I'm going to post. Link is up here above my head. If you, however, want to understand why does tangent and cotangent have a period of pi, where sine, cosine, secant, and cosecant both have a period of 2 pi, and you want to just see the relationship between the unit circle and the values for tangent, then watch this video, and we're going to set up just the basic tan and cotan graphs, and then do some examples in the next video. So here we have the unit circle. It's set up with all the radian values. And if you've been watching my videos for graphing trig functions without the use of a calculator, then you'll know that we only care about graphing the easy points. You know, the ones, the zeros, and the negative ones. So let's circle around this unit circle. Of course, I've got my answers already listed out here, but as we go around the unit circle and we start to work on graphing the tangent of theta, which is y over x on the unit circle, let's look at some of our values and look at how these values repeat around the unit circle. So we have the tangent of 0, which is y over x. Of course, that's going to be 0 over 1, which is 0. And now if I just continue to go around all the values on the unit circle, like pi over 6 and pi over 4 and pi over 3 and so on, you can see that we have a lot of decimals that we don't really want to graph when we're trying to make these by hand. So the tangent of pi over 6 is y over x. So it's going to be 1/2 divided by the square root of 3 over 2. And those common denominators are going to cancel out, getting you a value of 1 over the square root of 3. And then we never leave square roots in the denominator, so we have to rationalize that. And the tangent of pi over 6 is square root of 3 over 3. We certainly do not want to try and sketch that value when we're not using a calculator to help us out. The tangent of pi over 4, well, tangent is y over x. So it's not like sine and cosine and secant and cosecant, which always use the radius as part of their calculation. And because of that, when you look at pi over 4 and you see that it's y over x, you get the value of 1, because anything divided by itself is equal to 1. So we only had to go 45 degrees, or pi over 4 radians, before we found an easy value to graph of 1. If we were talking about sine or cosine, you would have to rotate 90 degrees or pi over 2 radians to get to that easier value of 0 and 1 that we use to sketch or graph it. So continuing on to pi over 3, again, tangent is y over x, the y coordinate over the x coordinate on the unit circle. Again, the common denominators of 2 cancel out, and we get another decimal value of square root of 3. And then at tangent of pi over 2, we get, again, it's y over x, the y coordinate over the x coordinate, and 1 divided by 0 is undefined. So a couple of things going on here. We can see that our easy values of 0, 1, and, well, this is sort of a weird value of undefined, but they're not going to happen at the quadrantal angles like they do for sine and cosine, and thus secant and cosecant. So that's an idea of how they're a little bit different. We will have places where when you're dividing y divided by x, or with cotangent, which is x over y, that leaves the possibility of x or y becoming 0. And those will be at the quadrantal angles. So there is a possibility, like we see here with the tangent of pi over 2, that it can come out to be undefined. Our graphs are going to have vertical asymptotes at those points where the x or the y's become 0, and thus you can't set up the tangent or cotangent function, and you get vertical asymptotes. Okay, around the unit circle, I've highlighted the angles that give us the easy values of 1, 0, negative 1, or in the case of tan and cotan, they can become undefined. Well, secant and cosecant have vertical asymptotes as well, because secant being r over r over x, and cosecant being r over y, those have the possibility of having vertical asymptotes as well. They do have vertical asymptotes. So we got these easy values that we're going to use to sketch the standard tangent and cotangent graphs in a second. And let's talk about why tangent only has a period of pi instead of 2 pi. So think of the cosine graph. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. So we've gone from values of 1 to negative 1, and then as we continue our circle around, the cosine of 3 pi over 2 is 0, and the cosine of 2 pi is back to negative 1. So those values for the tangent of 0, or excuse me, the cosine of 0, the cosine of pi over 2, the cosine of pi, the cosine of 3 pi over 2, and the cosine of 2 pi, hopefully my hand motion is enough. I'm assuming if you're watching a video about tan and cotan, you've already learned about sine and cosine graphs. Those values go from 1 to negative 1. Now, you start to climb back up again, but they're in a different order. So thus the period of cosine and sine is a full 2 pi. You have to go all the way around the unit circle before your values start to repeat, and they repeat in the same order. Well, look at tangent here. Tangent of 0, the tangent of pi over 4, the tangent of pi over 2, where it's undefined. The tangent of 3 pi over 4, where it's our first time we get negative 1, and then the tangent of pi is back to 0 again. So our values are 0, 1, undefined, negative 1, and we get back to 0. Now watch what happens. The tangent of 5 pi over 4, the tangent in quadrant 3, that's where we are, has a negative x and a negative y, so it's a positive value, and we get the value of 1 again, just like we had at pi over 4, the other side of the unit circle, or 180 degrees, or pi units away. Then go to 3 pi over 2. We're again doing y divided by x. X at this value, or at this quadrantal angle, is 0, and it's once again undefined. So at 5 pi over 4 and pi over 4, you have the same values of 1. At 3 pi over 2 and pi over 2, opposite sides of the circle, you have undefined again. And then at 7 pi over 4, because the x is positive and the y is negative, we get a tangent value which is negative, just like it was at 3 pi over 4. So you see, these values on the opposite side of the unit circle are repeating, and repeating in the same order. So you only have to go halfway around the circle, or pi radians, before your tangent values once again begin to repeat, and repeat in the same order. Unlike cosine that starts at 1, goes to negative 1 at pi, but then you start to climb back up again, and you'll see those y values repeat, but they're repeating in the opposite order. So you have not finished your first period yet. So sine and cosine, secant and cosecant have a period of 2 pi, whereas tan and cotan only pi. Let's set up cotangent for a second. The cotangent of theta is x over y. So all these yellow values are my tangent values. So cotangent is the reciprocal. Well, when you flip 0, you get an undefined value. When you flip 1, you still get 1. So the cotangent of 0 is undefined. That'll be a vertical asymptote. And the cotangent of pi over 4 is 1. The cotangent of pi over 2, if you take x over y, 0 divided by 1 is 0. At 3 pi over 4, you get negative 1 again, because the reciprocal of negative 1 is negative 1. If you take 0, cotangent of pi, if you take 0 and you flip it, you get an undefined value, or cotangent is x over y. Again, you can't divide by 0. So that's going to be undefined. And there is your first period of cotangent. And these values repeat around the bottom half of the unit circle. Let's actually look at a couple of graphs, shall we? Okay. Okay, let's straighten that up a little bit. Good enough. Alrighty, camera's a little bit crooked, but let's get going anyway. So y equals tangent of x. We're going to set up the parent function, no transformations. So we have a fake amplitude of 1, our leading coefficient is 1. I still like to point out this idea of fake amplitude, not because tangent has amplitude. It's not, there is, when a graph goes up and down forever, there is no height to take a half of, but I'd like my kids to see that when they go down their t-table by hand, if their values are not separated by units of 1, the sort of fake amplitude, as I call it, they know they hopefully found they made a mistake on their t-table. Period is pi over b, not 2 pi over b like it is with sine, cosine, secant, and cosecant, but pi over b, and that's pi over 1, which is pi. There's no parentheses, no addition or subtraction of a constant at the end, so the phase shift and vertical shift are both 0. And we're still going to count by a quarter of the period. So if you've been watching my videos about graphing sine, cosine, tangent, or excuse me, sine, cosine, secant, and cosecant, I'm going to say the same thing. Start your t-table at the phase shift and count by a quarter of the period. And here's our values that we had just on the unit circle a minute ago. Alrighty then. So here we've got a graph set up with the values that I have in my t-table. Well, if you connect these dots, you kind of get sort of a weird picture. When we graph sine and cosine, it was a nice flowy graph. This has a break right dead center of the period. It's kind of like 0, 1, and then boom, it's undefined. And then back to -1 and 0. So you might, the first time you graph tangent, want to, just extend your t-table a little bit to get you used to the pattern. Now, I know that 5 points will set up a 1 period of a trig function when you start at the phase shift and you count by a quarter of the period. So even though this looks funny, I do know that it's 1 period. So let's just start repeating the process, or the pattern. 0, 1, asymptote. So now I'm at 0, so my next tick mark over, again made off my values from the t-table, must be a value of 1. And then at 3 pi over 2, I have another vertical asymptote because it was 0, 1, asymptote. 0, 1, asymptote. So this is going to be my second period of tangent because the first period of tangent is generally looked at as the one that's around the origin. So 1, 0, -1. So 1, 0, -1. And what's next? Vertical asymptote. Good. This right here in the center is what you would see in your textbook when it shows you the first sort of like parent graph of, or the first period of tangent. You might notice some things about this. If you take this graph and you rotate it 180 degrees, it'll line up with itself. So this is an odd function and has symmetry around the origin. It goes up and down forever, so the range is all real numbers, or -infinity to +infinity. The domain is going to have this, it's almost all real numbers, except you've got these vertical asymptotes where tangent is undefined. So the domain is going to be all real numbers, except for where the tangent function is undefined. And that's going to change based on the period of your graphs, but you can just find like one place where there's a vertical asymptote, and then say, okay, it's all real numbers except whatever that value is, in this case pi over 2, and then plus or minus n, and then whatever your period is. In this case it would be plus or minus n pi, because this is a parent function and my period is pi. Your asymptotes are going to be separated by whatever the period is for your tangent or cotangent graph. Okay, I got 2 minutes left. Let me set up a basic cotangent function, and we'll get with you in just a second. Let's see here. Okay, what if this were cotangent of x? Well, the cotangent of 0, as we saw in the unit circle, is undefined. Then it goes to 1. Then it goes to 0. And then it becomes -1. And at pi, the cotangent of pi is undefined. Well, let's see what that would look like. At 0, cotangent is going to have an asymptote because it's undefined. At pi over 4, it's at 1. See, if you take 1 and you flip it, you still get 1. At pi over 2, it's going to be 0. At 3 pi over 4, it's -1. And at pi, it's undefined. So this is your first period for cotangent, sort of like your parent function, your parent graph for y equals the cotangent of x. I'm out of time. Next video, we'll be actually doing some examples that have some transformations in them. I hope I've helped you out. Go do your homework.